Hello to the people of this cruel world. What's going on? In this video, we will learn how to recognize handwritten digits with the help of something called machine learning in Python in just fewer lines of code. Now, if you don't know about machine learning, let me tell you something about machine learning. Machine learning is a way for the machines to learn something from the training dataset. So we will be providing the training dataset. In this case, this handwritten digits dataset is the training dataset so that in future it can predict the new data. So if you don't know about machine learning, you need not to worry about anything because we will not implement everything from scratch. We will be using a very famous machine learning library written in Python that is called scikit-learn. So you can go to the scikit-learn docs and read how you can install that package in your Python. So, and then you should download this data set which contains the sample images and a training. So you can go to this website. The link will be given in the description of this video, and you can click on this trend, and then you can download this training dataset. So I have already downloaded this, so I won't have to download this again. Now let's get started. Alright, so I created this Python script and I'm super excited. So let's do this. The first thing I would like to do is I'm gonna import some of the libraries like numpy as np, then import matplotlib.pyplot as pt. This is used for plotting the image. Then I'm gonna import pandas as pd. Pandas is used to load the data training dataset, and then from sklearn.tree I'm gonna import this decision tree classifier. This is the machine learning model. We will read the data set using pandas, and then we will give that data to this machine learning model for the training purpose. So let's try to import this data set using pd.read csv. Yes, then I downloaded this dataset into my datasets directory. Then the file name is train.csv. Now let's try to print this data. Okay, so you can see it has printed the entire dataset, which contains 42,000 row and 785 columns. So if you can observe among this 785 column, the first column is the label or the name of the digit, and this remaining 784 value is the intensity of each of the pixels of 28 cross 28 machine images. So they used to train this they created this data set using many of the samples of 28 cross 28 image, and they have put this intensity value in each of these pixels. Alright, let's try to clean this dataset and let's try to split this dataset for the training and for testing purpose, and at last we will be checking the accuracy. Now, this has given me a pandas data frame object, but I would like to convert this into two-dimensional numpy array using this as matrix. And if you don't know about numpy, matplotlib or pandas, you can go ahead and watch my previous video where I discuss about all of this, and the link is given in the description of this video. Now, I need to split this dataset into two portions, one for the training, another one for the prediction. So it contains 42,000 rows. So I will be using first 21,000 record for the training and the remaining for the testing. So before that, let's create an empty classifier using this decision tree classifier. So this would create an object of this decision tree model, and initially it's empty. We need to give some training dataset. In order to give the training dataset, it takes two lists. One is the list of feature and corresponding level. So list of feature in this case will be the intensity value of each pixel, and their corresponding level will be nothing but the digit. So let's try to take this, let's name it as xtrain. Xtrain will be data. I want to take the first 21,000 row starting from index 0, then I would take 21,000 row here, and then I should take everything except the first column. So index of the first column is 0, so I should start taking the column from 1 to remaining portion. That was it. Then their corresponding level, let's say this is train level, this is equals to data. Then starting from 0th to 21,000 element, I should take only the 0th column because it contains the level. So let's train this classifier using this fit method. So it takes the list of features and corresponding level, which is train level in this case. Alright, that was it. Now let's comment this out, training dataset, and I would like to create a subset for the testing data. So let's say that x test is equals to I would take data starting from 21,000 index to the remaining, and then I would like to take the first column on only, then actual level. This actual level would be used for checking the accuracy after actually predicting something, after getting the prediction from the machine learning models. So it would be very much helpful on that situation. Now I would like to take starting from 21,000 index, I would take every row, and then I just need the 0th column. That's it. Now let's try to take a sample from this test data set. Let's say that d is equals to x test, then I would like to take random, let's say the fifth element, let's say the, okay, eighth element. Then I would like to plot this, I would like to show how it looks like. In order to do that, I should reshape this into 28 cos 28, because now it's a row vector, so I need to convert that into 28 cross 28 matrix. Then using this PD, that is the object of pyplot, then I can write im show, then I can write this d, then cmap is gray. I would like to show everything in gray. Let's subtract 255 from here, because if I plot this directly, it will give me black background and white color, but I want white background then black color. So for that I will be using this, I will be subtracting this value from 255. Let's try to execute this code. Okay, it looks like 3. Now let's try to play with this learning model. It's ready for the prediction. Let's write something like print clf.predict. If I pass this d, okay, I cannot pass dd because it takes a single row vector, so it will be x test and 0. I need to just give the features, and then it will give me a level for that feature, and I need to encapsulate this inside a list. And let's try to see what it predicts. So it has predicted 6, but it's actually looking like 6 also. Let's test with another data. Instead of this 8, I would like to take 5. Okay, there was a mistake. I should give 8 over here, because I am taking the 9th sample from this test data set. If I execute this, let's see what happens. Now it's predicted 3. Awesome. So it's time to measure the accuracy. For that, I will be giving this entire test data set in this predict function, and then I would compare that with this actual level. Let's try to do this. That's gonna be kind of fun. So instead of everything, what I'm gonna do here, I'm gonna make let's delete all of these things. I would like to write, let's say p is the prediction. So what I'm gonna do, I'm gonna give this clf.predict, then this entire test data, that will give us a list of prediction, list of levels for each of the data. Then I would like to compare the accuracy. How do I do that? If I compare each value with every other value, then I will get the count of the matched value, then I can compute the percentage of accuracy. So let's say c count is equals to 0. Then I would like to run a loop for I in range 0 comma 21,000. Then I'm gonna do something like count plus is equals to 1 if p I matches with corresponding actual level, otherwise I would add 0. So let's try to print accuracy over there. Accuracy is equals to, okay, accuracy we should compute that in percentage, so that would be count divided by the size of this actual number of features, actual data, so which is 21,000, then I should multiply that by 100. So let's try to run this code. Okay, by mistake I multiplied that by 1000. It should be 100. Let's try to predict this again. Well, we got an accuracy of 83%, which is quite good. But you can play around with this classifier. There are many classifiers like k nearest neighbor, random forest, and so on. So you can search on the internet and you can see how many classifiers are there. You could try and use different classifier and see the accuracy. So that's it. If you liked my video, please subscribe.